Hi everyone. If you have seen my last video for plottings, multiple plottings in one picture, so I'm still going to use the same example here for moving ahead in our topic, multiple plots topic. I'm just going to give you a small overview about the example that I have used in my last video as well. These are the two import statements for importing the NumPy and Matplotlib library. I'm using two figure 1 and figure 2 identifiers for each figure to be plotted separately, showing two different separate plots. These are the three arguments, and using those arguments and arrange function, we are going to retrieve the t1 variable values. Then web values are to be computed using the sine function here, which belongs to the NumPy library. Then the first Fourier transform of the NumPy library will be able to calculate the one-dimensional discrete Fourier transform result values. Then lastly, the T2 argument for the frequency bins of FFT or fast Fourier transform parameters. Using all those four values, we are going to plot two graphs or two plottings um, in two figures. So if I will run the code, okay, here are the two figures, figure 1 and figure 2. So let's first see the figure 1 here. Here T1 is the time, and in the y-axis we have the amplitude, and the axis max and minimum values for y and x-axis are given as like this: -1 to -6 in the x-axis and -1.2 to +1.2 in the y-axis. This is our figure 1. Similarly, in figure 2, we do have a plotting involving the T2 and the absolute value of the FFT result from this. X-axis does contain the frequency and magnitude in the y-axis, with having the x and y-axis coordinates as given in this axis function. So there may be some conditions where you want to have all the plottings. Let's say you don't have two plots, rather than you have 10 plots. At a certain point of time in one code, you are writing the code in certain way that 10 number of plots to be created or populated in 10 different windows, like this: figure 1, figure 2, figure 3, like this up to figure 10. So it's not something easier to get track of or keep track of all these figures. So if there will be a certain way where you can have these figures located in one figure, so it will be easier to compare all those plots. So how to do that? To achieve that kind of plotting visibility, we should make some changes to our code. So there is one function called subplot function. I'll be using this in my code, and which will allow the multiple plots to be created in a single figure, with each subplot having its own set of axes. And subplots are often preferable for multiple figures when related data is plotted. So let's make some changes to our code. I'll still be using the figure and figure 2, figure 1, figure 2 unique identifiers, but before that I need some changes here. I'll be using a subplot function. I want two rows, um, then one column, and the first and the location one of the first figure. So this is how the subplot function is used. Then I want to keep this statement for plotting x level, y level. Yeah, I'm not going to change anything in here. And then again, I'll use the same subplot to add the second figure or second plot to the same picture or figure again. So we have two columns two rows, one column, and here the location of the second figure will be a sequence in 2. Yeah, so that much is enough. Let's see it's working or not. Yeah, so here's he. Before we had two figures and in them we had two separate plots. First plotting was in the first figure and the second plotting was in second figure. For rather than having two separate pictures here, I have just added the subplot function to have both of the plottings in the same figure. This is how you can use the subplot function. There is another way I'm going to show you in the plotting. Let's say you want to add uh, two y-axis into your plotting. So how to do that? Okay, so we are going to use this code here that you are viewing currently, and the new thing that you are going to learn is your twinks function. So before going to the function, let's just first go through the code here. We'll be using the matplotlib pyplot. I will be using this file ddStats. In the ddStats, we have two columns with some set of values. So first least we are keeping track of is total fatalities and then the alcohol fatalities. Then the next one is percentages. So for each line in the F, the file object, so each will take the values as a line from both the columns in one row and just split them or separate them together using the split function. um, so total, the left hand side column value will be assigned to total and the right hand side will be assigned to alcohol. Let me show you this file so it will be easier to track actually. Here it is. I have already opened it recently. Yeah, so this is the value and this is the value in two columns. So first row as a line, we are trying to split it into two different values, total and alcohol. Let's close this. Now total fatalities will be appended with all the values from the total list and the alcohol to alcohol fatalities, and the percentages will be appended with alcohol divided by total multiplied by 100. So we are going to use the total fatalities, alcohol fatalities, and percentages in our plot here. So years is another one variable which keeps the range in between 1970 to 2012. We are supposed to use years also in our plot. So let me run the code and show you how the plot actually looks like. So here see, we have one x-axis year, in the y-axis we have number of highway fatalities, and in the right hand side y-axis we have percentages fatalities involving alcohol. So the year uh, argument will have all the year values falling in between 1970 and 2010. The number of highway fatalities will be included from the total fatalities and alcohol fatalities. And here in the right hand side is the percentages of fatalities. So these are the values we will be using. So see, there are three graphs actually, three plots actually. So the blue one is associated with the total. Okay, and then orange one is alcohol used with the alcohol fatalities value, and the percentages here is involved with the dotted red plotting here. So how to have achieve this kind of plotting? So first we have to use the figure function in order to um, create the figure argument. So our program here is going to add a new data series showing the percentage of fatalities related for the alcohol for a given year. So y-axis values of this percentages will range from 0 to 100 in the right hand side, while the y-axis values for the number of highway fatalities will range from 0 to 60,000. and a separate y-axis is required. Otherwise, the percentage data series would be indistinguishable from 0 once the plot is scaled. And it seems like a little confusing, right? So we will see all the instructions in here. So okay, so we are going to mm, use this new function called add subplot. So when it is called, it returns the subplot axis. So actual, what is this? Again, the actual creation of default subplot is not important or necessary, and how it will be done. So which row, which column, and which location. This is how the plotting will be located. Then we have one twinks function. Let me just tell you something about it. The twinks function is called to create the right side axis. So here it is the percentage title. It is involving alcohol. So only we can apply the twinks function in such a case where the x-axis values are common to both of the y-axis values. This is the case where you can use this kind of function, that is twinks. The left and right axis will be used to set the axis levels, plot data series, and enable the legends on the top, as you see. So let's move over to our code here. Okay, so first created the figure. Then the left axis for the location, we are using the add subplot. So the whole plotting will be in the first row, first column, and first location. Then right axis is supposed to be used with twinks function. So the using the left axis and the twinks function, we are going to create our right axis aligned. Now the left axis plotting, so this is something we are dealing with total fatalities. The left axis plotting will include the years as x-axis, total fatalities labeled as total. This is something we are dealing with our blue plotting here. And then again in the left hand side axis also, we are going to use the alcohol fatalities again with the years as x-axis, alcohol fatalities as the y-axis in the range of 0 to 60,000, and it is labeled as alcohol related. Now the dotted one, it's something your right hand side or right axis plotting, which will include the year as the x-axis, percentages that we have from here, this list will be labeled as in your y-axis, and which type of format do you want. Red hyphen hyphen, that means the dotted plotting, red color dotted or dashed plotting, and label is alcohol related, so which will be populated here in the right hand side legend, upper right hand legend. Now the left axis label is to be labeled with year so that we can see year here, and the y left axis y label will be labeled with number of highway fatalities. Then left axis legend, something that we want, it should be located in the upper left corner. So this is how you need to specify the location. Then right axis set y level. We need to name this y level in the right hand side as well. So this is how it will be named. Percentage fatalities involving alcohol. Now the right hand axis legend, which should contain the percentage alcohol related, should be located in the upper right corner. Then just use the show function to populate this plotting. So these are the mostly used functions that we use for multiple set of plottings in multiple figures. One figure, um, if we have multiple plots, they can be populated in one figure, or you also can have this type of plotting as well, with having multiple y-axis plotted along side one x-axis.